Welcome back. Today I'm thinking we'll do 3 of the levels all in one video. So we'll start with the AND gate. So we can use the NAND and the NOT that we already have. And going from a NAND to an AND is really easy. It's in the name implies that a NOT AND can be converted back into an AND by just NOTing the output again. So if we do that, then we only get a true when both inputs are high. Next is the NOR gate, but we still can only use NANDs and NOTs. And we want to flip it so that it's only true when both inputs are low. But what we have to work with is only false when both inputs are true. So in this case, you have to do something where you NOT the inputs. So you actually take a NOT from both of them, and then you get your output. So let's see what we get. Oh, so we get the inverse of what we want. We want true and we get false, and we want false and we get true, true, true. So we can easily solve that by just adding another NOT. The last one is the OR gate, but we've already solved this, so we just don't need that final NOT on the output. Check the truth table. And we've got it. Alright, so here in CRUMB, we're going to put down a NAND gate and also a NOT gate. And I've already got wired up a switch for the 2 inputs and then 4 output LEDs. So first we need to wire up grounds and VCCs for these 2 chips. And now we'll first just make the NAND. So we just put the 2 inputs in, and then we can route it around, and we can check, and yep, so only when they're both high does the light turn off. And then we can get to the NAND really easily by just routing that same thing to a NOT gate. Then we can route this to the AND, and we can check that, and now
It's essentially the opposite of the NAND. Now when we want to get to the OR, we have to not both of the inputs. So we'll take one to that one and one to that one. Oh no, not that one. Go to the 3A. Now we can route those outputs to our next AND gate. We'll do the one on the top here. And we can grab this output, take it all the way to the OR. And now we have the OR working. The last piece is to just, again, knot it. So we'll take it into 6A. And then bring it to the knot. The NOR. So if we try all the combinations now, got 1 0, 0 1, and 1 1. So I've got a NAND gate right here, a 0 0, and next to it I've got a NOT gate plugged in. So we've already got the NAND wired up like we had before. So it only turns off when both inputs are high. And now we're going to make the other 3 gates. So the AND is pretty easy, like we saw. We just need to take our output of the NAND and go straight to a NOT. And then we've got an AND. So then it's high when both the inputs are high. And that's the only time. Next, we need to NOT both of the inputs. Let's see if I can get a wire for that. Need a longer wire. So now we have A knotted and B knotted. We take those and we put them back into the NAND. We can go to one of the gates on the top here. And if we output the result of that one, so we have an OR now because we knotted both the inputs and then put it into a NAND. We can get an OR out of that by again knotting the output. So we take this and we go to our next NOT gate. And we put in our last light. Now it's high only when both inputs are low. So here we have it. We have low, low, high, low, low, high, and high, high.